The Keck Observatory Archive, COA, is a NASA-funded collaboration between NEXI, the NASA Exoplanet Science Institute at Caltech, and the W.M. Keck Observatory in Hawaii. COA curates nearly all of the raw data since the observatory began operation. This presentation will provide some background information on COA and the types of data and services we provide to the astronomical community. The W.M. Keck Observatory operates and manages twin 10-meter telescopes situated near the summit of Mauna Kea on the Big Island of Hawaii. At an elevation of nearly 14,000 feet, this site provides some of the best atmospheric conditions for astronomy and is also home to many other telescopes. The Keck telescopes are among the largest optical telescopes in the world, and when coupled with state-of-the-art instrumentation, allow ground-based access to extremely faint objects. The instrumentation on the Keck telescopes is quite varied and should suit the needs of most observers and archive users. 4 of the optical instruments, DEIMOS, ESI, HIRES, and LRIS, are capable of single-object spectroscopy. DEIMOS and LRIS are also able to perform multi-object spectroscopy through the use of image masks. HIRES is commonly used for radial velocity measurements of exoplanet host stars and is the only optical instrument that does not obtain wide.
And the Keck interferometer. LWS is the only Keck instrument that obtained data well beyond 5 microns. As the name implies, NERC was the first generation of the near-infrared camera used to obtain high-resolution images. The Keck interferometer combines the light from the 2 telescopes to provide visibility and nulling data. COA provides science products only for the Keck interferometer. COA ingests and curates the raw data for all of the active and retired instruments on the Keck telescopes. Although COA did not start actively archiving data until 2004, data in the archive date back to 10 years prior, shortly after the start of the first science observations on Keck 1. At the end of each night, the data are processed at the observatory and are prepared for ingesting and archiving at NEXI. In most situations, the observers can download their data from COA within 10 to 24 hours after the end of their observations to help visuals and bias rated in contributing reduced Keck data for hosting at COA. We encourage you to consult the guidelines for contributed data on our website and contact us with any questions. The Keck telescopes have observed objects in our own solar system, high redshift quasars, and nearly everything in between. Often, new reduction techniques applied on these older data can reveal valuable new information that was previously not possible. COA does not have information on the types of objects that are observed because such information could be misleading. For example, an observer may be targeting a specific star in an image, but that image may contain a galaxy that is important for someone else. Searching the archive using a list of objects of a known type, like exoplanet host stars, is the best method for determining which of them have been observed with the Keck telescopes. COA has several services to help you search our archives and find your data of interest. First and foremost, our web-based user interface allows you to search on parameters such as date, position, instrument, and program information, to name just a few. While performing these searches, you can choose to also return calibration files, such as darks, flats, and bias frames that would be appropriate for reducing the raw data. Objects in our solar system move rapidly across the sky, making positional searches for them problematic. To help with the discovery of moving object data in the archive, COA has a moving object service that uses JPL's Horizon system to generate an ephemeris, which is then searched against the positions of observations in COA. If your object is relatively new and is not yet in JPL Horizons, The service also allows you to enter the orbital elements for that object. In 2021, a major driver for COA will be the completion of full data access to the archive through our new programmatic interface called PyCOA. PyCOA is a Python-based package available through PyPy and is underpinned by Nexi Tap, a Nexi Python-based server that implements the International Virtual Observatory Alliance Table Access Protocol. PyCOA provides many convenient functions that allow queries by date, object name, and position. In addition, users can enter more complex queries in the IVOA astronomical data query language. Currently, only sidereal object searches of high-res and DEIMOS observations are available through PyCOA. But throughout 2021, we will be adding support for the rest of the instruments, adding the ability to query for solar system objects, and providing access to calibrated data. By the end of the year, PyCOA will replicate, and in some cases exceed, the searching functionality on our web-based interface. Documentation for PyCOA on the COA website includes a Jupyter notebook with many examples of the supported query methods. New users looking for a quick way to get started with PyCOA are encouraged to download this notebook. COA provides downloadable text tables of the public data for each instrument. Users with thousands of positions they want to check against the archive may find offline searches with these tables more efficient than uploading their list to the web-based interface. In the future, our Python interface to our holdings should largely eliminate the need for these files. For certain types of quick-look reduced products, COA provides tools to help visualize the data. These include the ability to examine high-res one-dimensional spectra, flat-fielded NERC2 images, and three-dimensional cubes from OSIRIS. In addition to the data obtained by the Keck instruments, COA also gathers weather data relevant for the observatories. These are available to download or browse on a night-by-night basis. The NASA Exoplanet Science Institute has created a service that reduces Keck high-res data directly from the Keck Observatory archive and produces high-precision radial velocities for high-res data taken with a specific set of instrument and observing parameters. In addition to processing new data, users of the service have access to approximately 60,000 radial velocities computed from compatible high-res data going back to August 2004. Because this service is adapted from the pipeline used by the California Planet Search team, users can expect nearly identical results to CPS. In fact, 82% of the computed radial velocities are within 1 sigma of the CPS results. Please note that a COA account is required to run this service, and interested users are encouraged to check out the Nexi website for more information. The Keck Observatory, in collaboration with COA, has started a data services initiative that will focus on the management of data from the preparation of the observations to their ingestion into the archive. This initiative will allow for the real-time ingestion of data so that observers will have immediate access to their data through COA. Furthermore, both observers and archive users will benefit from improvements in the metadata, which will better track the intended use of the observations. For example, sky frames can be distinguished from science frames, data within a dither pattern can be flagged, and the exact files needed for proper calibration will be identified. With this information, data reduction pipelines producing science quality data will be possible. Currently, COA only performs simple data reductions for some instruments. These are not intended for science and should only be used for assessing the quality of the data. A multi-institutional group is now designing and writing software to be used to create science quality data from automated pipelines. These data will be served through the archive along with the raw data. Ultimately, DSI and the subsequent pipelines will increase the scientific productivity of the observatory and the usability of the data. Stay tuned for more information. Thank you for watching this video discussing what the Keck Observatory Archive offers and how it can help with your science. We invite you to look at our site and encourage you to write to us if you have any questions.
All right, thank you so much for that video.
All right, thank you. Sorry for all the glitches on that.
I apologize. I did lose my internet connection for about 30 seconds there. So that was the fastest login I think I've ever done in my life. I hope it didn't disturb your enjoyment too much.
So we're gonna start question and answers now. You guys can either put your questions in the chat box and we can read them from there, or you can unmute yourselves and ask your questions there.
One thing to note is that before questions come in is that we'll be having office hours for COA tomorrow from 10 through 11. You can access it through the Nexi booth. We'll be giving demos of the Python services, answering questions, and giving demos of anything that anyone wishes, anything else that anyone wishes to see.
I'll also point out you can also see an uninterrupted version of this video on through the Nexi booth. So,
yes. There's a question from Mike Wood. Is there a rough timeline for when the pipelines that automatically produce science quality data will be available? Do you mean the pipelines available for end users to run, or pipelines that will be used to create products for COA? I'll try and answer both questions since they're related. That work has been funded by a special award from NASA to the Keck Observatory. COA is a participant in that grant. These pipelines will be made available within the next 3 years. That's the duration of the project, and producing the pipelines obviously is one of the major goals, one of the major deliverables. So they'll be made progressively available between now and 3 years from now. New instruments that are built will have a pipeline delivered. It's a requirement from the observatory, in fact, that a new instrument has to have a working pipeline when the instrument is commissioned. So those will be available when instruments are commissioned. In fact, I'm working on the pipeline for KPF. I'm doing the system engineering for that. And then when that's delivered in a couple of years, the pipeline will be available automatically. Once the pipelines are made available and they're operating, COA will use them each night to create science products that will be delivered through the archive. They'll be subject to the same proprietary period as the raw data, but the pipelines themselves will all be written in Python from now on, and the code will be made freely available to everyone. So if you want to do your own reductions or do updates to pipelines, you'll be able to do that. And as Dawn points out, the KPF is the Keck Planet Finder. One thing perhaps Anastasia didn't mention in the video was that the Python client code will eventually be made freely available for open development through GitHub. It's not available right now because archive users told us that it was far more important to have instruments accessible through COA then being able to edit the code or make contributions to the code. So having the other instruments available is our immediate goal.
As well.
Yes,
Thank you.
Thank you all for coming and listening.